This is the third unit syllabus ma. Here you have to first one structuring the computation. In that structuring the computation we are having expressions and statements. In that expressions and statements we are having these topics ma. Conditional, execution and iteration, next routines, next one exceptions, next one pattern matching, next one non-determinism and backtracking, next event driven computations, next one concurrent computations, next one have structuring the program. Next, this is the next second chapter in the third unit ma, structuring the program. In the structuring the program we are having software design methods and concepts in this, support of modularity, and next language features for programming in the large and generic units. These are the topics under the third unit ma. In this third unit we divide two chapters. First chapter is structuring the computations and expressions and statements. Next, under this, these are the topics. Next chapter is structuring the program. In that structuring the program you have to know about the software design methods, concepts in support of modularity, language features for programming in the large. Next, generic units. These are the topics under you have to know in unit 3. Here, next, first topic. In this first topic, structuring the computation. Here in this structuring the computation we are having first topic is expressions and statements. Here what is meant by expression? Here expression is combination of operators and operands. Here expression is combination of operators and operands. Here expressions define how a value can be obtained by combining other values through operators. Here expression is combination of operators and operands. Here in these expressions you have to define how a value can be obtained by combining other values through operators. Here in this expressions, for example, we are having C equal to A plus B. That is called expression. Here expression is, for example, it takes C equal to A plus B. Here C equal to A plus B. That is called expression. Here collection of operators and operands is called an expression. Here A, B, C are the operands plus equal that are called here as operators. Here expressions define how a value can be obtained by combining other values through operators. That is called as the here expressions. Next point is operators appearing in an expression denote mathematical functions. Here operators appearing in an expression denote mathematical functions. Here in this operators appearing in an expression denote mathematical functions. Here this is characterized by the arbitrary. RT means here number of operands is called RT. Here they are characterized by their RT. RT means here number of operands, and it is invoked by using the function signature. Function signature. Here it is characterized by their RT. These are called number of operands. Here we are invoked using the functions signature. Here in this operators we are having two types of operators here. First of unary operator, second one is binary operator. Next one is binary operator. Here a unary operator is applied to only one operand. Here unary operator is applied to only one operand. Next one is binary operator. It is applied to two operands. 2 operands. Here a unary operator is applied to one operand. Next binary operator is applied to 2 operands. Here next point is n array operator. Here next point is n array. N array operator is applied to n operands. Here unary operator is applied to only one operand. A binary operator is applied to 2 operands. Here n array operator. N array operator. It is applied to 2 operands. It is applied to 2 operands. Here regarding the operators notation, we can difference between the infix, prefix and postfix notations. Here regarding this operators notation, we can define or we can distinguish between the infix, prefix and postfix operations, postfix notations. Next, next here we are having infix notation, prefix notation, postfix notation. Here infix notation, it is the most common notation for binary operators. It is the most common notation for binary operators. The operator is written between 2 operands. Here infix notation, it is the most common notation for binary operators. Here in this infix notation, the operator is written between 2 operands, as in x plus y. As in, for example, you take x plus y. This is the infix notation. Means here this notation, it is used for the binary operators. Next, this operator, it is written between 2 operands. 2 operands. This is the 2 operands. Means here x y. X plus y here. X is one of operator, x is one operand and y is operand. Okay, now this is called the infix notation. This is the example for x plus y. Next, prefix notation. In this prefix notation, the operator appears first. The operators appear first. Here and then operands as plus xy. Plus xy. Here in this prefix notation, the operator appears first and then the operands as in plus xy. Plus xy. For example, you take plus xy. Means in this prefix notation, the operator appears first. The operator appears first and then operands and then the operands. Example has plus xy. Next, in postfix notation. In postfix notation, the operands are followed by the corresponding operators. In postfix notation, the operands are followed by the corresponding operator as xy plus. As xy plus. For example, you take xy plus. Means here the operands are followed by the corresponding operator. Corresponding operator. That is called the here postfix notation. Postfix notation. Here next. Here next point here expressions in prefix and postfix forms may be written without resorting to parentheses. To specify some of the sub expressions that are evaluated first. Here expressions in prefix and postfix forms may be written without resorting to parentheses. To specify here sub expressions that are evaluated first. Here. For example, we take the infix expression here. We take the here infix expression a star b plus c. This is the infix expression. Here next prefix expression. it can be written as A star B plus C. It can be written in prefix form as star A plus BC. A plus BC. Here these expressions in prefix and postfix forms can be written without resorting to parenthesis. Parenthesis means here brackets. Parenthesis means this bracket and this bracket. Infix form is like that. A star B plus in parenthesis B plus C. But in prefix and postfix forms, expressions in prefix and postfix forms may be written without resorting to parenthesis. First, you have to specify this sub expression that are evaluated to first. For example, it take this infix expression A star B plus C, means we have in this B plus C is in parenthesis, means this is the sub expression for this whole expression. A star B plus C, this is the whole expression. In this B plus C is the sub expression. B plus C is the sub expression. That's why we have to write like this: star A plus BC. Star A plus BC. Here for this have to write postfix form. A B C plus after that you have to multiply star. After that you have to multiply star. Here this is about the expressions are involved in like this. Expressions are in prefix and postfix form may be written without resorting to parenthesis. Next point. Next point here, in C language we are having some of the languages. In C language we are having the increment and decrement unary operators. Here in C language we are having increment and decrement unary operators. Here we take unary and binary. Unary operators are, these are plus plus, this is the increment operator. Decrement operator consists of minus minus. It can be written as minus minus. It can be written both in prefix and postfix notation. Can be written both in prefix and postfix notation. How we write these unary operators used in prefix and postfix notation means these are both expressions are plus plus k. We take the here plus plus k here. Plus plus k is the increment operator. Prefix increment operator. And next and k plus plus and k plus plus. K plus plus means this is the postfix increment operator. Postfix increment unary operator. It has the side effect that is stored value by k. Stored value of k is incremented by only 1. Means here increment operator means pre-increment prefix. We have to use the prefix means we are having operand. Before operand we give the symbol, that is called the prefix. Here postfix notation means we give first, we get the operand, after that we get the operator. Okay, likewise in C language we are having increment and decrement unary operators. It can be written both in prefix and postfix notation. But here both expressions are plus plus k and k plus plus. It have the side effect that has the stored value of k is incremented by 1. Here in this case the value of the expression is the value of k incremented by 1. In this case the value of the expression is the value of k incremented by 1. Here for example that is the first the stored value of k is incremented and then value of k is provided as the value of the expression. That is called the here former case. In this former case here in this former case the value of expression is the value of k incremented by 1. That is first the stored value of k is incremented and then the value of k is provided as the value of the expression. As the value of the expression. Here next infix notation, it is most natural one. It is used for the binary operators. Infix notation, it is most natural one to use for the binary operators. Here it allows programs to be written as conventional mathematical expressions. It allows programs to be written as conventional mathematical expressions. This infix notation, it is the most natural one to use for binary operators. Here it allows programs to be written as conventional mathematical expressions. Conventional mathematical expressions here. Here for example, you take the convention, it is adopted by most languages. It is adopted by most languages. Here in this infix notation, it is written as conventional mathematical expressions. Here this programmer may use the parenthesis. Programmer may use parenthesis to explicitly group sub-expressions. Group sub-expressions. Here it must be evaluated first. It must be evaluated first. After that, programming languages complicate by introducing their own conventions for operator associativity and precedence. Operator associativity and precedence. Here to facilitate the programmer's task by writing the expressions, how to reducing the redundancy. Here, but this can generate some confusion. That's why we make much understandable for less understandable. Much expression less understandable. Here to make expression less understandable. Especially here when switching some languages, for example, have to adopted by these languages such that like this. Here a plus b star c. A plus b star c is interpreted implicitly as like this. Here a plus b star c. First you have to use the parenthesis. Means a plus b star c. A plus b star c. That is multiplication has precedence over binary addition. Here multiplication has precedence over binary addition. Here it is a standard mathematics. For example, here it is a standard mathematics. Here we have to consider the in Pascal expression. Pascal is one of the language Pascal expression. In this Pascal expression, in this Pascal language, the expression like this. Here a equal to b less than c, and c expression is like this. A equal to b less than c. A double equal to b less than c. This is the c expression. This is the, you have to consider the Pascal expression like this. A equal to b less than c. This is the Pascal expression. This is the c expression. In C language we have that expression. A equal to b less than c. Next in Pascal language, operators less than and equal same precedence. Less than and equal have the same precedence, and the language specifies that application of operators with the same precedence. It precedes the left to right. Means the here in Pascal language, less than and greater than symbol have the same precedence, and this language specifies that application of operators with the same precedence, it proceeds to left to right. Here the meaning of the above expression is that the result of the equality test. The meaning of the above expression is that the result of the equality test. Here a equal to b. Result of the equality test, a equal to b. Here which is a Boolean value. Boolean value. It is compared with the value of C. It is compared with the value of C. It is must be a Boolean variable, which must be a Boolean variable. Here in Pascal language, false is assumed to be less than true. Here in Pascal language, false is assumed to be less than true. So the expression yields true only. The expression yields true only if A is not equal to B and C is true, and only if A is not equal to B and C is true. C is true. Here in Pascal language, false is assumed to be less than true. False is assumed to be less than true. Here, so the expression yields true. So the expression yields true only if A is not equal to B and C is true. And C is true. Here it yields false. Here it yields false in all other cases. It yields false in all other cases. For example, if A, B, C are also false. If A, B, C are all false, the expression yields false here. Expression yields false here. In Pascal language, operators less than and equal has the same precedence. That's why here false is assumed to be less than true. Here such that expression yields true only if A is not equal to B and C is true. That time it yields false. It yields false in all other cases. For example, you take A, B, C are all false. That expression yields false here. In Pascal language like that. Next point here, in C language, operator less than has higher precedence than equal. Here in C language, less than has higher precedence than equal. Thus first B less than C is evaluated. Such partial result is then compared for equality with the value of A here. Here in C language, operator, we take the operator less than has a higher precedence than equal. First B less than C is evaluated. After that, the partial result is compared for equality with the value of C. A. For example, we take here B equal to A less than C. B equal to A less than C. Here first you have to evaluate B less than C. A less than C. Here I take here A equal to B less than C. Here for example, you take A equal to B less than C. First you have to evaluate B less than C. After that we get the result is stored in A value. First you have to evaluate which operator? Less than operator. That's why here less than has higher precedence than equal operator. That's why in C language, less than has higher precedence than equal operator. For example, another example, have to assume A equal to B equal to C equal to false. Here assume A equal to B equal to C equal to false. Here represented in C as 0. It is represented as C in C language. It is represented as C as 0. In here, the evaluation of the expression, it yields 1. Here in which C stands for true. Here C stands for true. Next point here, for example, having it is a define a new type. Set. Here one can define the operators plus. We can define the operators plus. Plus is used for set union and minus is used for set difference. Set difference. Here for example having a defined a new type set. Here one type can be defined, the operators is plus. Next for set union, next minus is used for difference, is used for difference. Here some languages, here this example is regarding to the C++ and ADA. Here some languages like C++ and ADA allow operators to the programmer defined. Here in this some languages like C++ and ADA, they allow operators to be programmer defined. For example, have a defined new type set. One can define the operators plus for set union and minus for set difference. Here next point is the ability of providing programmer defined operators has another feature, that is that feature is based on the overloading. In some cases make programs easier to read. In other cases harder. Here readable in this readability is improved. In this case readability is improved since the programmer use the standard operators for the infix notation. Here in this for the effect of this feature here is that several actions for the program is proceeded here. For this effect of this feature means, what is the feature means here, this readability is improved since the programmer is allowed to use standard operators. For the infix notation here, for this only defined types. It is only defined types here. Next, the effect of this feature in which several actions happen here when the program is proceed. That is good whenever happens the behind here the programmers, whenever the effects are to the programmer. Here next some programming language here, ability of writing conditional expressions. Here these expressions are composed of expressions of which only one is evaluated depending on the value of condition, Here this some programming languages has support the ability of writing conditional expressions. That is, the expressions are composed of sub expressions of which only one is to be evaluated. Here it is depend on the value of a condition. For example, in C language we can write like this: A greater than B question mark A colon B, means this is a ternary operator. You have the ternary operator. First this condition you have to check. For example, here we take this is a ternary operator. This expression is called an ternary operator. For example, here A equal to, here first A, for example, A equal to 3, here B equal to 4, here A equal to 3, B equal to 4. I gave A equal to 3, B equal to 4. Here 3 greater than 4. Condition false. Condition true or false? Condition false. If the condition, first you have to evaluate this in this parenthesis, A greater than B, means 3 greater than 4. Condition false. But condition false time, that's why we go for, we print the B value, means B value, B equal to 4. Here you have to check which value is the greater. Which value is the greater here. We are giving the two variables of that values. Which value is the greater? I gave here A greater than B and next A or B. Next I gave here A greater than B. Means I gave here A equal to 3, B equal to 4. 3 greater than 4 means 3 greater than 4 means condition B equal to 4. Here A means 3 greater than 4, condition false. That's why B value is print, means B equal to 4. Here it in this expression it is only to be evaluated here. It is depend on the value of a condition. It is depend on the value of a condition here. Here it can be written more conveniently understandable form in ML. Form in ML has in ML. What is meant by ML is ML. It is one of the language here. It is one of the language, means meta language. One of the meta language. ML is the meta language. Next, in ML we have to write like this. If A greater than B, then A else B. Then A else B, like this. If A greater than B, then A else B. Here A greater than B. For example, A equal to 3, B equal to 4. A equal to 3, B equal to 4. 3 greater than 4. 3 greater than 4 means then A else B. A else B means 3, then A. The condition true, you have to A value is, you have to print the A value. The condition false, we get the B value. Here I gave A equal to 3, B equal to 4. 3 greater than 4, condition false. That's why we got the here B value. B value. Next, it is to yield the maximum of values of A and B. Maximum of values of A and B. Next, here ML. This meta language allows for more general conditional expressions to be written using the case constructor. By using the case constructor. This is the following example. Case x of equal to 1, f1 of y. Here f1 of y equal to 2. Here case x of 1. Case x of 1 here 1 equal to f1 of y or 2. Case 2 to f2 of y or g of y. Means here this is the in ML language case x is false. Case x is true, we get the one f1 of y. Case next, this condition is true false. This condition true, it will print. This condition is false, we go for this case. Next we go for this case. Okay, now this is the in ML you have to use the case constructor. By using the case constructor here. Another example we can write like this: asterisk p plus plus equal to asterisk q plus plus. Here in this right hand side, this in right hand side expression, it yields the value pointed by q. Here. Here this is the in left hand side, it is an expression, it provided by the r value. It is a r value, means r value means we give the reference value. That is an L value. Here next, here like this. Since the above assignment you are getting here, the left hand side is an expression, it provides the r value of p, which is the a reference, that is an L value. Here overall affect the value of the object pointed by q is copied into the object pointed by p. Both pointers also incremented with an side effect. Here the above assignment of an expression, the value of the expression is that of the object pointed by q. Here for example, we take the following concise means clear. Clear piece of code. It copies a sequence of integers. It is terminated by 0. next it is pointed by P into an sequence pointed by Q. For example, here while asterisk P plus plus equal to asterisk Q plus plus not equal to 0, not equal to 0. The condition here in this sequences as for the simplest form of the compound statement. These are the simplest form of compound statements. Here the syntax of the language in this each statement in a sequence, it is separated from the next by semicolon, next by semicolon. For example, in Pascal language a sequence can be written as like this: begin, stat 1, stat 2, so on, state. Here state means statement 1. How to begin? Statement 1, statement 1, semicolon, statement 2, next statement n, end. Here in C language, here have to write like this: while asterisk P plus plus equal to asterisk Q plus plus not equal to 0. This condition have to check like this. But in Pascal language, here you have to write like this: begin, statement 1, next statement 2, next statement n, statement n, end, statement n, end. This is the above the in this the syntax of the language requires the each statement it will be separated by the next by a semicolon, next by a semicolon. Next begin, stat 1, next stat 1, stat 2, start, state n, end, statement n, end. Next other languages instead have to require each statement to be terminated by a semicolon, each statement to be terminated by a semicolon, and do not need any special separator symbol, do not need any special separator symbol here. For example, in C language you have to write like this: statement 1, statement 2, statement n, statement 1, statement 2, statement n. For example, you have to write like this in C language.